Nice. Jav, do you want to review the blockers? Again, we did them yesterday in APAC, but I guess totally different crowd. So do you want to just give us maybe an overview of where we are with those?
Yeah, sure thing. So no update on enabling live traces. Just checking to see, yep, nothing new here. Support for the dependency proxy, I think this is done. I think this was. Yeah, so it says this has been fixed for GitLab, fixing GitLab for 13.3. So we can take a charts update for this. We haven't actually bumped the charts version, but we should probably do that soon.
I have an MR for that, Jarv.
You have an MR for it? Okay. NFS dependency on pages. Jakob is working on this. Hopefully this will happen soon. And then I don't think there's been any significant update for mapping services to cloud native, but we're not completely blocked. We're just going to be blocked very soon as we finish the Git HTTPS migration and state-of-the-art logging, which is a funny title, but this is just what it happened to be when it was submitted. But yeah, it sounds like we may use the sidecar approach, and I think I owe Maren an issue in the GitLab tracker for trying to see if we can fix this at the application by annotating logs with the source. I think this is going to be problematic though, just because we also have the unstructured logs like the production.log, application.log, all this stuff. I'm not sure if there's much we can do with the app, but we can see. Any comments on those blockers? If not, we can move on to the demo. And I guess I have the first one. So we finished the HTTPS Git migration for staging, and we're going to probably start with the production. Well, we will start with the production migration next week. My plan for next week is to have Canary running, by the end of next week, to have Canary running in Kubernetes, as well as some of the production traffic. And what I'll do is I'll use the Kubernetes cluster as like a single server in the list of servers, so that we take like maybe single-digit percentage of traffic to the cluster. So we'll start with Canary and then move to that. We'll probably let it sit like that for a while, and then maybe the following week we'll do the full migration. Finished staging so far. I mean, there weren't really any issues. Of course, staging doesn't get a lot of traffic. You can see here links for the logs for Rails and Workhorse. I am a little bit concerned about log volume because, a little bit different than what we have now is that we get all of the logs going to the Rails index, and all of the logs, well, just the Workhorse logs for the Workhorse index, but for the Rails index, we're getting like the production.log, application.log, all of these are going to it. Yeah, I guess there isn't a whole lot to see.
Obviously, that's not going to be with the product, especially with the Rails log, right? Like that's not something we can kind of use for anything, right?
Maybe this, well, so maybe this sidecar should be a blocker for us going to production if we're worried about it. I think like we're going to increase the volume by quite a bit and also have a lot of junk in the Rails index that we don't want to look at.
Yeah.
And Maren's nodding his head, yeah. I think so, yeah.
Yeah, I think we talked about it a bit yesterday. I just don't remember what I said because it was yesterday. So, yeah. I mean, I think it should be a blocker. And actually, I think I said that in the end after you explained how it is not, right? Or no, how it was,
Yeah.
but in longer words, right? I remember.
Yeah. Yes. Yeah, I guess. Okay, so we're going to make that a blocker, which means that we may be delayed on getting production migrated because of it, but I'll update that issue to let distribution team know that it's a blocker, and we'll probably have to tackle it next week.
And we don't have an alternative, right? Like it's really a blocker, because if we get this in production, we are A, running blind, B, spending money like crazy, C, probably crashing everything left and right.
Well, we're not running blind, but we're kind of overdosing on stimulus, like it's like too much because we're getting all these unstructured logs as well. It's just like, it's really ugly.
Yeah. I suppose we could filter for what we need, but yeah.
We can filter, but
ideal.
it's a bit ugly, because we'd have to filter based on the log message. So not be very nice.
I mean, if we could just turn off if it was urgent that we got this into production and we wanted to avoid the blocker, could we not just turn off the production Rails log? And then everything else would kind of be okay.
But then
it's only that one, and no one uses that. So
we
don't want it. No, I challenge anyone to make any sense of the production Rails log, the unstructured one.
Yeah, I've tried this
GitLab.com. It's ridiculous.
Oh yeah, I understand now.
Yeah, it's just
for a single node installation, you can still sift things a bit. Yeah, I get it now. Yeah.
Like for us, it's like drinking from 100 fire hoses.
Yeah, the big ones as well, right? Like the fire truck ones.
Yeah. So I mean, that would block you, right, Jav? Just turning that off somehow, if that's a possibility.
But I don't know whether that's possible.
Just can't you not read it?
That's the problem. Well, we'd have to adjust CNG because it tails everything. It just blobs. I think last time this came up, there was some pushback. So I'll have to look at the issue for that. But
I mean, I'm genuinely surprised that anyone that runs Kubernetes would find those logs useful. But anyway, that's like.
Okay, let's table it and we can discuss.
Yeah.
But obviously, it's a high priority thing if it's going to block us. This is the dashboard, the pod info dashboard, which is just a copy of the existing dashboard we have for Sidekick and Mailroom and 2ML. I guess the thing to note here is for staging, I'm using the default requests and limits. So we have limit of 1.5 CPU and gigabytes, 1.5 CPU and 2 gigs of memory. If we look at the usage, I mean, it's very spiky because it's staging and we're pretty much only hitting HTTPS Git when QA runs. So you can see that we're spiking up over a core on some of these. So I'm not sure, maybe we're gonna have to adjust the limits a bit. For memory, it looks like that, we're also kind of spiking up on memory and going up to 3 gigabytes. Limit is set to 2, so I think we need to do some investigation here to see whether maybe our limits are too low. So next is there's a new issue for kind of summarizing where we are in the migration after a year. And one thing I put together today is this dashboard called the Kubernetes Migration overview efficiency dashboard. What I did is I totaled up the number of cores and the amount of memory that we were running on VMs prior to the migration. This has remained fairly stable. I don't think we've added, I'll have to double check, but since we started the migration, I don't think we've added many nodes in the web or API or Git fleet. But anyway, I did include it's up to date for Git web and API, and it has a number of cores that we were running in Sidekick right before the migration and registry and mailroom. So we had 1,500 cores we were running on VMs, and you know, about 5,000 gigabytes of memory. So I have two panels here. This is actually a little bit negative. I'm not sure why this single stat. I have to figure out. Or no, it's actually not negative. Never mind. It's very close to 0 though. So maybe that's why it's showing 0. But it's kind of funny if we add up the number. So I have the total number of cores for virtual machines right now, and the total number of cores in the Kubernetes cluster right now. And if you add these up, and as well as the number of memory, we're sitting at approximately about the same amount we were running under VMs, which kind of makes sense. Like we're about even. So what I'm hoping is that right now we're a bit over provisioned in the Kubernetes cluster. So what we can do is hopefully like drive this memory savings and CPU savings up a little bit, so that the total amount of cores and the total amount of memory is like less than we were running prior to the migration. I'm not done with this dashboard yet. I plan to add some more things. What I want to do is break it out by service and show like the total number of cores and memory and utilization per service, as well as maybe showing like both node auto scaling and HPA scaling to see how it's working in Kubernetes. Is there anything anyone would like to see here? Or first of all, I guess, do you like this dashboard? Because I don't want to spend too much time on it, but I thought it was kind of nice.
It could be just my day to day and the warmth here, but I'm really having a bit of a trouble understanding the numbers I'm seeing.
Sure.
So are you is this the current state? As in, there is no historical comparison, right? Like if we are going to say registry from August 2019 and registry from August 2020, we can, like, this is what's happening right now. Is that correct?
Yeah, so this is the current state, and the way I'm calculating the savings is by putting the previous state in the denominator. So you have like, this is the number of cores that we were running. These are the number of cores we were running without Kubernetes, and this is like the amount of memory we were running without Kubernetes. What it's taking is the total number of cores between VMs and Kubernetes and dividing it by the number of cores we were running prior to the migration. So as we like shift cores over from the VMs to Kubernetes, this number might remain the same, but hopefully like we're utilizing cores more efficiently in Kubernetes, and that number will, like the savings will increase.
Yeah, I guess what I'm missing here is, well, first of all, the services. You said you're working on that. That's going to be a good thing because it's going to allow you to, right? Like we're mangling too many things at the same time. So it's hard for me to understand, for example, specifically for registry, what's happening. What would be actually also interesting to know is if there is a way for us to say like what kind of number of requests were we serving at certain points. So for example, if we were serving 1,000 requests in August and we are serving 15,000 requests now, we're doing better or worse.
Yeah.
Andrew has a weird grin. What kind of stupid thing am I saying? Andrew, please correct me.
I see what you're saying. Like basically at the time when we were running this number of cores and this memory, you want to know how many requests we were serving. And because obviously like it could be that we're saving more cores and memory because like the number of requests have increased.
Yeah. It's very difficult over time to, I understand, and I think it's, but the problem is like the workload changes. So if the workload was like fixed, then it would be very easy to do that calculation. But obviously, you know, endpoints get more efficient and endpoints get less efficient. And so you're trying to juggle like lots of different variables. And
right, but it's still, right, like, but that's going to be a small bump, right? It's not going to be a big change, right? Like if you improve the efficiency of registry itself, sure, you'll see a bit of a bump. It's not going to be precise comparison, but it's going to give you.
Yeah, like if you aggregate it over a longer period, like if you took a month-long period and you said, right, in this, like not a short period, not like an hour or a minute, but you said in this month, you know, the growth was 3% on this month, and we used 20% less cores or whatever, then that would be valid. But I think if you were looking over a short period, it would be.
I would be even fine with a quarter. Like we don't need that precise of numbers. Like 1/4 of this is the average we had, and this is the average we have now over this quarter.
And we have that. If you're trying to get hold of that, the best way is the GitLab service ops recording rules have got all that in it, and they're highly aggregated, so we can actually query them for more than 30 seconds in Thanos without it timing out.
Yeah, I think though we'll need to look back, like for registry. We really want to see this for registry mailroom, right? And for this we need to go back in history.
Mailroom, we don't have any. Mailroom, you can't look at that. Though.
Yeah,
Mailroom.
Registry, like maybe. So
registry, we've got quite a lot, and we'll have that going back at least a year.
Okay, so what we need to do is, like, at the time when we were running 8 cores and 30 gigabytes, how many requests we were seeing at that time, and then we can compare to the number of requests now.
And if you just use increase on GitLab service ops, blah blah blah, you'll find that.
Yeah. Cool, but yeah, I mean, I was kind of surprised to see that we're about even right now, but I guess not too surprised. Like,
when you say even, that's including the web and API fleet though, right? Or am I misunderstanding that?
Yeah, so first of all, this includes everything except Pages, Patroni, Redis, Giddily, and Prefect. So all the stuff that we're going to migrate over. When I say even, what I'm saying is that, like, before, like, we were on VMs, we had 1,514 cores. If you sum up the total number of cores between virtual machines and Kubernetes in the Kubernetes cluster now, we're about at 1,500.
Right. I didn't realize you were including the VMs as well in that calculation.
Yeah. Because what I want to see is
just
like,
Kubernetes.
No. Because this so what we should see is, like, this should stay, well, at least should stay around 0, but hopefully we'll improve a bit. Like we'll increase it.
I mean, my gut is that,
again, like, even if we don't see improvements there, if we are serving more traffic, because I would expect that, right? Otherwise, we have a bigger problem if in a year we didn't see any change in the traffic, right?
Well, keep in mind that GitWeb and API are, like, the services that we are scaling the most, and these are snapshots of today, not like a year ago. Registry is a snapshot of a year ago or so, but registry, like, we typically don't have scaling issues for registry. At least on VMs we didn't. Like, we were running a static set of VMs for a pretty long time, and Sidekick was similar. Like, I think
well, Sidekick was similar because of the other actions that were happening, right? Like the mangling of Sidekick left and right to try to make it perform, and scaling Redis up to take all of that in.
Yeah, so I think it's difficult, but I like just being able to see, like, the number, keeping a tally of the number of cores and the amount of memory we have in the cluster, and making sure that's under control. Like, because
it's also an option, Jar, if you don't want to go overboard on this, like, keep this dashboard and improve it the way you want it, but just do like in a Google Sheet. This is the amount of cores we had before the migration. This is the amount of requests we had. This is the amount we have right now. This is the amount we have of requests right now. Like, it can be as simple as that, and then we can just plot that very low level.
cool.
Will this end up being a way of us actually seeing some of the kind of progress of the migration as well? So I'm guessing we'll see, like, number of cores coming down and on the VMs.
Yeah.
Like, I guess it's not like a hard progress tracker, but, like, it's a little bit of a visual, right, of progress.
Yeah, it should. Like, the number of cores for VM should go to 0. When that goes to 0, we're done.
We're done.
Yeah.
Cool.
Or we are just beginning. Right?
Yeah, we got a long road.
Yeah, we're done except for Pages and some Sidekick and, like, yeah.
Exactly.
Yeah. Cool. Okay, that's all I got. Next up is Andrew.
Okay, cool. I don't know how deep to go into this, but I can give you a quick demo of what I did I think it was last week or the week before, we were talking about how to figure out which Sidekick jobs are talking to NFS. And the two approaches, maybe I should close the door. Give me 1 second. Oh, sorry. Kids decide to start playing outside my room as I start talking. So basically the two approaches are, one, we like send a message to Sentry like every time an access happens, or we do something like that, which is the approach that we used on GitLab when we were doing a similar sort of migration to move away from NFS near the end of the GitLab project. And that was pretty successful. But this is kind of like, it was a bit more of a risk. But the idea was we could use kernel instrumentation to trap the NFS calls and then figure out what was going on at that time to figure out what's making NFS calls. And so it's a little bit more risky. So I thought I'd give it a try and just spike it. And if that didn't work, then we could go to the other route, which is sort of less risky, but it's also more invasive. Like we have to get a whole bunch of stuff into the application and then, you know, get that through and turn feature flags on and off, where this is kind of like much more sort of low touch. So I thought I'd give it a try. Let me share my screen quickly. Also, if like you know, just if you have any questions, let me know. So basically the way it works is I used a library called GoBPF, which is so BPF is a kernel, is a set of tools where you can write like C code and like good old fashioned C, and then that C gets compiled and gets injected into the kernel. And the reason why like this is phenomenal and incredible and amazing is that in the past, if you wanted to run things in the kernel, you know, you'd have to be like a hardcore kernel developer and spend years writing device drivers and like even longer before you put anything into a production environment. And the thing with BPF is that it's got a thing called a verifier, which takes a look at your code and guarantees that it's safe, right? So it is impossible to write BPF code and inject it into the kernel that is not safe. And so it's got a whole bunch of limitations, like you can't have a for loop, which is pretty standard. But the reason you can't have a for loop is because then it doesn't know that the program will ever end. So you could kind of just go around and around forever. And because you can't have a for loop, like comparing strings becomes quite difficult, because, you know, if you wanted to compare two strings, you have while loops and you kind of iterate through them. And so there's a lot of stuff that's kind of weird, but it's actually also surprisingly powerful, and people are doing incredible stuff with it. But this is a very, very simple program. And all it does is it's got these entry points. And when something happens, a little bit of code gets called. And in this case, what's happening is that whenever an NFS operation, a write operation, a read operation, or a file open operation, I can't remember if I did get attributes. If any of those calls get called in the kernel, this code gets executed, and all it does is it gets the process ID of the process that's running, that made the call originally, and then it sticks it into a table and then pushes that table up to userland. And then in userland, there's a Go program that I wrote that basically reads all of those events, all the processes that are doing NFS access, and then does something with it. So in this case, what I did was when the program runs, it monitors the Sidekick log, you know, the good old fashioned JSON formatted Sidekick log that we've got. And it keeps track of all of the start job events. So when a job starts, it gets emitted with the process ID of the job and obviously the name of it or the class of the job that was running. And so what I do is I tail that thing, and if it says, you know, let's say a webhook worker started and it was on PID 53, then I keep a hash table in the Go program which says, okay, process ID 53 is a webhook worker. So that's running along on the one side, and on the other side, I installed the BPF program into the kernel, and it's telling me process ID 5 did NFS, process ID 10 did NFS, and then if it matches up, if it says process ID, say 53, did an NFS right, then I'll know, haha, process 53 is a webhook worker. And so using those two things, I can say, well, it's probable that a webhook worker was doing NFS work. The only sort of requirement is that we don't have more than one, a concurrency of one in Sidekick. And the reason why we can't do that is because if you have 10 different things running inside a single Sidekick process, we don't know which one of those 10 things was the thing that did the NFS, because we can't go to the thread level. We can only go to the process level. Although now that I'm thinking about it, I think we could do that if we just add a small thing to our logs. But let's see how well it goes on. So basically what it does is it's tailing the log, it's picking up all the start events, and then it's tailing all the NFS, well, monitoring all the NFS activity. And then what it does with that is every time a job starts, it increments one Prometheus counter. And every time an NFS access happens for that job, it increments another one. And so theoretically, what you could do is you could run it for 12 hours. And at the end of it, you could say, like, what are the percentages? And anything that's above a few percent. I suspect that there will be like a few things where the timing between what we get from BPF and what we get from the logs isn't synced. So there might be some sort of overlap on some calls. And so there might be a very low probability of us getting the wrong values. But there will be some webhook, or sorry, not webhook, some Sidekick jobs where we have a very high indication that they're doing NFS. And so we can take all of that and we can say these are likely to be NFS workers, and the ones that have just got like 1 or 2 or 3 NFS accesses, that was probably something else. And so it's kind of a sketchy kind of idea, but it didn't take very long to write this. And it just basically tails the log, parses it out to JSON, looks to see if it's a start job, and then associates that job with the process that's running it, and then polls NFS, reads the BPF data from the kernel here. And it actually works pretty well. So am I sharing my whole screen? I think I am, yeah. So Skarbek has set up a machine that's running Sidekick with concurrency 1, but Skarbek, it doesn't look like it's actually running any jobs.
It's pulling only from the default queue at this moment in time. I have not moved anything over to it just yet.
Yeah, because there's no NFS traffic on that box, so it doesn't work particularly well. I can give you a demo on Catch-all if you're interested in seeing how it works. Pardon me?
Do it up.
Cool.
I want to see a demo.
So demo in production.
Second one in a row.
So basically what I was doing, so most of the time for actually putting this together was getting a Linux environment that matches our Linux environment with the same version of BCC. So we're actually running a very old version of BCC. So that was the most difficult part, was getting that all working. So basically I set up a Vagrant box, good old school Vagrant, and got it to be the same version. And then I could compile it on there and then copy it around and then run it. So basically, let me just remind myself which port. So when this starts up, it will listen on 10.282 and it will have metrics there. So if I go like that, it should fail. And the reason it fails is because it's tried to inject BPF code into the kernel, and the kernel's not happy about it because it's not root. So either you can give the program privileges or you can run it as root, but it's pretty safe. And then if we start letting that run, basically now, what was the name of port again? So we can just ask Prometheus what's going on. And the demo has not worked. Oh, the reason the demo hasn't worked is because I'm on the NFS box, which is not the machine we want to be on. So let's go. Sidekick. Sorry, so I was on the catch NFS machine where I meant, because this window is quite narrow, I meant to go into the catch all machine where there is actually NFS traffic. So let's try that again here. I happen to know that I've copied it on. Sorry, if I do curl, sorry about the, I don't know if you can hear the kids having a nice fight next door. So basically what we've got here is these are just Sidekick, Prometheus metrics. Let's open this up a bit. And you can see that Sidekick NFS monitored jobs started. It's got the name of the class and the number of jobs of that class that have started. So you can see it's picked up 6 of those, you know, however many of those. And then down here, it's picked up the number of NFS monitor accesses that it's picked up. Now, the problem is in this catch-all fleet, it's actually going to be slightly wrong because it doesn't know how to attribute. So basically at the moment, it's made an assumption that there's a concurrency of 1 and there's not. So, you know, the concurrency is 8 or whatever. So it's pretty much wrong and you can't rely on this. But once we have the catch NFS fleet working, we can test this properly and it should work. And the numbers should be correct. But you can see it's working. It's picking up and it's associating jobs with the you know, NFS accesses with the different Sidekick jobs. So it seems to work. And I'll just kill that off. And it uses about 10% of one core in terms of CPU. So it's not free. But on that machine that's got the you know, concurrency 1, we probably have a bit of extra.
It'll be a pretty
CPU
big
anyway.
machine, so there's
Yeah.
plenty of runway.
Cool.
So do you envision, or I guess a good question for you is, should I just consider moving every queue in catch-all, just making the same configuration that we have in catch-all over to the catch NFS server?
I mean, like the other thing is, if we know that there's jobs that absolutely don't have NFS access, it'll kind of validate the script because, you know, hopefully what we'll see is that there's no NFS access is being attributed to those jobs. And if we do get like high NFS access, then maybe this isn't a great approach, but at least it'll help with that.
I'm thinking, my initial thought was, because I've got a lot of people working on filling out this spreadsheet, I figured there's a lot of defined no's, like they don't require shared storage. I thought maybe I'd take all of those no's that people have indicated to me and just moving those over first and let it sit for a while. Validate that we have processed those jobs just to knock out a good chunk of this list.
Yeah.
I mean, this spreadsheet's probably maybe 50% filled out.
Yeah.
But we also have ones that we know we can't migrate over. So, you know, just exclude those from the list of migrating over to this box as well.
Yeah, I mean, however you want to, like, obviously because we have lower, like the way that this works is statistics. And so, you know, like what you want is like a high probability that when these jobs run, they are doing NFS. And in order to do that, we need to kind of focus and run as many of those jobs as possible. So obviously if we are spreading out and running a lot of jobs that we know don't have NFS on that fleet, we're kind of taking away the sample size from the ones that we do want to run that with. So I think initially it's like good to test it with that, but then eventually just kind of leave it on the unknowns. You know, obviously the known yeses and the known nos, or sorry, the known NFS accesses and the known non-NFS accesses we can kind of ignore, and then it's just whatever's left. How do you want to, the one thing I was wondering is, do we want to just kind of grok the, like sort of grep the ports, or do you want to connect it up to Prometheus, or?
It might be nice to have this in Prometheus. Like, yes, it'll be easier just to not do that, but I think it'd be pretty cool to have it in Prometheus just for historical purposes, at least.
Yeah, could do that. The only other thing is it is running as root. So I don't know if we want to have it binding for too long. The other thing we could do is we
Good
could
point.
just give it the permission that it needs, which is, I don't know, some BPF thingamabob. You know, we could give it that one permission. Like I presume that's what we did, because we've got an eBPF exporter running on all the nodes already, and presumably that's not running as root. So, you know, we're already doing that on our fleet, and that might be a safe way of doing that.
All right, maybe we could check that out at some point.
I'll ask Matt Smiley. I think he did it.
Okay, cool.
Cool. Cool.
So hopefully either later today or next week, I'll start moving queues or modifying the configuration to get something running on this server. Only
Cool.
spun up one box.
Yeah, I think that's fine. Yeah.
I couldn't decide whether I should spin up an entire fleet or whatnot, but I thought if I only spun up one box, it'll be easier to look at just one system containing all this data versus moving the script across 7 nodes and that kind of thing.
Like if we find like I think I mentioned before, like I think I would trust the results after there've been like 1,000 invocations of a job, right? And if we're struggling to get that many, then maybe we need more nodes. But like you just saw, I ran that thing now, and there was like a lot of jobs, right?
Quite a bit,
yeah, I mean, it was a lot higher than I actually expected. So, you know, hopefully we'll get something like that on that new node.
Cool. That's excellent.
Awesome. Cool. I mean, it's still, I wouldn't bank on it as like it might still, you know, when we tested with the concurrency one, it might still all prove to be terribly wrong. But so far it's been
as
pretty
far
positive.
as evaluation goes, I've got a list. Do I have that issue on my screen somewhere? I don't. I had a list of all kinds of things to watch for when it comes to doing the migration and the evaluation. So my goal was to look at Prometheus, and we got the node mount stats NFS operation requests total metric that we could utilize.
Yeah.
We could also look at Sentry, and because I only spun up one server, it makes the Sentry query super easy. So if we get errors from trying to read or write, granted, we're not going to get errors because NFS is mounted, but when it comes to the point when we decide to turn off NFS on this box prior to actually start the migration to Kubernetes, we could start looking at Sentry for those errors. And then we could also look at our existing dashboards to determine, well, you built that into the script, but we still have our existing dashboards as well to look at determining how often those jobs were called upon. So we have a few things we could look at is what I'm trying to say.
Yeah. Awesome. Frisky cats.
Yeah. Well, he's also half blind, so he doesn't know how much he needs to jump sometimes. And he runs into me quite often, but, you know, life goes on.
Awesome.
So, yeah. I think we're in a good state so that next week we'll be able to start knocking some stuff down.
Yeah. Cool.
Cool. On your final one, Andrew, I mean, it's a great question about I don't know if it's directly related to the Kubernetes migration, but it does raise a good question of whether we should be discussing those sorts of things, the deployment stuff as well. But like, I'm guessing, like, it's up to you, Job. Scuttleback, are you keen to see another dashboard?
There's actually no dashboard yet, so
the beginning to a dashboard. Yeah. I think it's I thought in my head it's like a fully formed existing thing. Yeah, I get that. It's an MR.
I put that in there thinking Leslie was going to be here so that we could kind of run through it, but he's kind of the main target. But if you're interested, we had a really good call this morning to kind of figure out what we're going to do there. And basically what it is we're going to have a separate set of thresholds for monitoring for release purposes, and they're going to be much stricter then, so basically what happened was we decided to use the monitoring thresholds that we use already. And then this morning there was a bit of a hiccup, but it wasn't enough to basically wake someone up. And so the thinking was, we've kind of optimized the alerting to be about like not waking people up. But actually the thresholds that we want for starting a deploy, it'd actually be ideal if they were decoupled from that. So we could kind of move them up or down. And, you know, if we make them tighter, we don't have to worry about whether that's going to be people getting pager duties on the weekend. So we've basically split it into 2 different thresholds. Same metrics, but with 2 thresholds.
Nice. That sounds great.
So yeah, cool.
Awesome.
Okay.
Is there anything else
have a lovely
anyone wants
weekend.
to go through? No? All right. Thanks very much, everyone. See you next week.
Bye.